So we have two trolleys X and Y connected by an elastic cord. Trolley X is twice the mass of trolley Y. The two trolleys are pulled apart so that the elastic cord is stretched. The trolleys are then released at the same time and move towards each other. The trolleys stick together on impact. Just before the trolleys collide, the speed of the trolley X is 20 centimeters per second, and we need to find the speed of the trolley after they collide. So, how do we approach such questions? We will use the law of conservation of momentum, which states that the initial momentum is always equal to the final momentum, but there is a condition involved. And what is that condition? So, let's read this. Initial and final momentums are always equal if there is no net force acting on the system. So, here we have two trolleys X and Y. Both of them are being pulled together by an elastic cord, but we are going to consider both the trolleys plus the elastic cord as part of one system. Now, if all these three are part of one system, then whatever forces are there in the elastic cord, that will be internal to the system. So we will say that the net external force acting on this system will be zero, and then we can equate the initial and the final momentum. So how do we approach such questions? Step one is always to draw the diagram. So we'll draw a before and after diagram. The before diagram is the one which is already shown that the two trolleys are released. First of all, the elastic cord is stretched. The two trolleys are released so that they start moving towards each other. Eventually, what is going to happen? The two trolleys are going to hit each other, and that will be the before situation. So, let me show you. Watch. Before situation, the elastic cord has been stretched. There are pulling forces within this elastic cord, because of which trolley X is going to go to the right side and trolley Y is going to go towards the left hand side. So, this is the before case. Afterwards, what is going to happen when the two trolleys hit each other and combine to become one big object? Both of these objects will move together as one system. Now, in the question, it was mentioned that trolley X is twice the mass of trolley Y. So we can assume that the combined X and Y system will move to the right hand side with a speed of V. And this is the V which the question wants us to find. What is the speed of the trolley after they collide? So according to the law of conservation of momentum, initial and final momentums are equal if there is no net force acting on the system. So in the before situation over here, let's go back to the question. It was saying the trolleys are released at the same time. Now, since they are released, which means the initial velocities for both the trolleys is zero. Both the trolleys are instantaneously stationary at that point. So we will consider initial momentum of the system in the before case will be considered as zero. So let's write down the momentum before B is before will be equal to zero. And according to the law of conservation of momentum, even the final momentum needs to be zero. So let's write down momentum in the after case will be equal to zero. So when the two trolleys combine together to become one big object, even then the total momentum of the system should be zero. Now, in the after case, what will be the momentum? Let's write down momentum in the after case. Momentum formula is mass into velocity, but in the after case, both the masses are going to be added together. Since it is given in the question that the trolleys collide and then they stick together on impact. So the momentum will be mass will be added. So we'll write mx plus my, that's the combined mass, multiplied by the common velocity of this entire system. Now, since we have already proved that the after momentum is also zero, so let's equate that equal to zero, which means we can easily say V, the combined velocity, will be equal to zero, which means once the two trolleys collide, they will stop. None of the two trolleys are going to move in any direction. So let's go back to the options. The answer would be option B, which is 0 centimeters per second. So this is the first method to solving this question, which is the easiest and the fastest way. But for some reason, let's say if this method does not click in the exam situation, then we can always use the basic law of conservation of momentum, which is just equating the initial and final momentum. Let's proceed with that. So it's the same question here, two trolleys X and Y. So in the before case, it is saying just before the trolleys collide, the speed of the trolley X is 20 centimeters per second. So let's say 20 centimeters per second. Let's convert that into meters. So 20 centimeters per second will be zero point 0.2 meters per second. So just before the trolleys collide, the speed of trolley X is zero point 0.2. In that case, let's say y would have been moving with a speed of x. Now, back to the same law of conservation of momentum. Momentum before and after will be zero. The before momentum is zero because the two trolleys were released at the same time. So initially, both the trolleys were stationary. So initial momentum definitely is equal to zero. So in this case, if x is moving to the right hand side with a speed of 0.2, so let's write down the total momentum. Momentum is mass into velocity. So for x, the momentum will be mass of x multiplied by the velocity, which is zero point 0.2 plus mass of y multiplied by negative x. Why we are taking negative x? Because x, the velocity, is towards the left hand side. That is why we are taking the negative sign. And this entire momentum is equal to zero. Now, in the question, it is mentioned that trolley x is twice the mass of trolley y. So let's consider mass x as 2m. On the other hand, let's consider mass of y as m. And let's try to simplify this equation. So we'll get zero point 0.4 multiplied by m, that will be equal to m into x. This implies on solving, we will get x is equal to 0 0.4, which means before the impact, y trolley is moving with a speed of 0.4 meters per second, but towards the left hand side. All right, now coming to the after case when the two trolleys are colliding with each other. So let's draw the diagram. So here we have x and y connected. Basically, they impact and they are colliding. After the collision, both the trolleys will move together as a system because they are getting stuck on impact. So let's say the overall velocity is v. So the final momentum, what will be the after momentum? So mass of x was double. So we'll write 2m multiplied by v. Rather, since both the trolleys are acting as one system, so we will add the two masses. So x is 2m, y is m. So the addition will be 2m plus 1, 2m plus m, which is 3m, multiplied by the combined velocity. So the total momentum after the collision comes out as 3m into v. And after momentum is supposed to be equal to the initial momentum, which was 0. So we equate 3mv to 0, which gets us v as 0, which means the combined velocity is 0. And that's what we had figured out earlier. B was the answer, 0 centimeters per second. So in this approach, although we had found out the velocity of trolley Y just before the impact, but it was really not necessary to be doing that. So I explained that just for the sake of understanding the law of conservation of momentum in an exam scenario. It is the method one, which is the shortest and the smartest way to solve this question.